Welcome, everybody, to Science Unplugged. My name is Greg Carbonetti. I'm sitting alongside Wendy Hom. We are from Stony Brook University, namely the Alan Alda Center for Communicating Science, and we are a show by scientists for non-scientists. What we're trying to do is demystify the stigma that surrounds science, that it's this big, complicated endeavor that I'll never understand. You certainly can, and we're hoping to help you learn a lot of new things. I'm certainly going to learn a lot of new things. And I think we got a pretty cool episode today. Who do we have with us, Wendy?
Today we have a familiar face, Stephen Jaret,
What's going on, Stephen?
Hey, Wendy. Hey, Greg.
And I think we were going to start with a few questions here for Stephen. So namely, I guess right out of the gate, do you want to lead the way, Wendy?
What do you do?
So I'm a planetary geologist, which means that I'm a geologist, but I study the planets. So I study the Earth, and a lot of the applications of what I do also is to understand the rocky planets like Mars or the Moon.
So I thought they all had, they don't, I know there's a lot of water out there and stuff, but there's some that are rockier than others?
Right, so the solar system's divided into several different kinds of planets. So we have the rocky ones, you know, Mercury, Venus, Earth, and Mars. And I put rocky planets, I also include things like the Moon, even though the Moon is not technically a planet.
Yeah, you're about to rock my world. I was getting really confused.
And asteroids, they're not technically planets, but they're rocky. And so from a geologist standpoint, rocks are rocks, right? And so whether or not it's a planet or an asteroid, if you're going to study the geology, it's rocks. Then you go further out in the solar system and you have the gas planets. So Jupiter and Saturn. Those we call the gas giants. They are mostly gas. They may or may not have some solid core down in the center, but they're less solid, and so the people who study those tend to be people who study atmospheres and gases, very different from studying rocks.
Makes sense. That was actually my next question. So we've got these, you know, rocky planets versus these gaseous planets, and you study the rock aspect. So what is it about rocks that we can learn about our solar system?
So specifically what I do is what we call geochronology, which is a huge jargony big word.
Like
exactly. Chronology dating. So
chronology, time. It's starting to make sense.
So I try and figure out how old rocks are. And so my lab uses radioactive decay. The way I like kind of thinking about this like an hourglass, where you have sand in the top of the hourglass and you turn it and then sand moves from the top down to the bottom. And if you know how long it takes for sand to move through, you can just collect up sand in the bottom. And so in geology, certain minerals have radioactive elements in them, and they operate sort of like a clock, like an hourglass, where they change from one element to another, and we can use that to date things back in time.
Interesting. So by doing this dating on these rocks that are, you know, coming from all over the place, because you go out into the field and you look for asteroids and stuff.
You actually travel to these places.
So
what can the time aspect tell us about our solar system and space in general?
So what I look at is meteorites and meteorite impact craters. The really cool application for this is to try and understand Mars. So we have a kind of meteorite called Martian meteorites. And these are actually, they're so cool. I love these things. They're like the coolest things in the world. So they're actually pieces of Mars that we have here on Earth, even though we've never actually been to Mars with people.
Not with people yet.
And even the robots that have been there haven't really come back with samples. They're working on it, but they haven't done that yet. But what we have had is where an asteroid slams into the surface of Mars, throws up a whole bunch of rocks that actually escape Mars.
So it's got to be like a huge impact for that to happen?
We actually don't know exactly the size. There are lots of people who are trying to calculate and estimate how big it would take to launch off Mars.
Can you tell when it has landed on Earth? Or that's harder to figure out?
That's part of what I'm working on and part of what I'm trying to figure out. So they get launched off Mars, and then they're floating around in the solar system for some amount of time. And they go toward the sun, and since, you know, if you're going toward the sun from Mars, you're going to cross Earth's orbit.
Yes, you get a little closer to us.
If Earth
the best planet, by the way. Earth.
I agree. Earth is the best.
That's why we're here.
So if Earth happens to be at the same place where these asteroids or Martian asteroids are, then it will get pulled down to the Earth. And so they come through the atmosphere of Earth. They land on the solid part of the Earth, which, you know.
You can study.
Yeah, but percentage-wise, there's significantly less solid land on the Earth than water. So we found it, and then we figured out they're from Mars.
Interesting. So I got two quick ones for you here. the low-hanging fruit here is like, do I need to be worried about getting hit in the head with like a Martian asteroid at any point? Are these like real big or are they like super tiny?
Most of the Martian meteorites that we have are not super big.
Okay.
But they're also really, really rare.
Okay.
You don't need to worry about getting struck by an asteroid.
I have a
Okay.
naive question.
Yeah.
What's the difference between a meteorite and an
Oh,
asteroid?
excellent question. So geologists really like classifying things. We sort of obsess over classification. And so the different terms are just basically where they are. So out in space, if it's still in space, it's called either an asteroid or a meteoroid.
Okay.
That difference is based on size. If it's really big, it's an asteroid. If it's smaller, like, basketball size or head size, it's a meteoroid.
Gotcha.
If it enters the Earth's atmosphere and it's falling through, and you see these as like a shooting star, we call those meteors. So we drop the oid part. And then if it lands on the ground and we pick it up and we have it as a rock, we give it the suffix "ite" because geologists call everything something "ite." So we call it a meteorite.
Okay.
All right, so you got these asteroids coming from Mars that are landing, and hopefully they land on the solid surface and not the water so we can find them. You go out and collect them. So how can you tell it's from Mars? And what information can we glean from these? Well, I guess they're meteorites now that they're on the Earth, right?
Yeah. So the way they figured it out, I think, is actually really cool. So when rocks form on the surface of any planetary body, particularly these kind, they're volcanic rocks. So things like basalts.
Yep.
And they erupt on the surface and they trap atmosphere in the rocks.
Okay.
So the same thing happens on Mars. When Martian lavas are erupting onto the surface, they're trapping atmosphere, but they're not trapping Earth atmosphere, they're trapping Martian atmosphere. So if you heat these rocks up, you can actually release some of the gases. And when they did these on the meteorites, they didn't know they were from Mars at that point. They were looking, and they heated up the rocks, released the gases, and the gases didn't look like Earth atmosphere, they looked like Mars's atmosphere. And we know what Mars's atmosphere looked like because of rovers that have landed, particularly the Viking spacecraft, had measurements of what the Martian atmosphere looked like.
So we've got, we've been able to identify that they're from Mars. We've been able to realize that the atmosphere are the same. I gotta ask you, all right, so we got this really cool rock. What about it? What can we do with that?
So one of the big questions for planetary geology is sort of differences between the various planets. Why is Earth different from all the other planets? Earth today is a very active geologically, very active planet. We've got volcanic eruptions going on. We have plate tectonics. It's a very different world from the other planets. And so one of the big questions in Mars is, when did Mars stop being geologically active?
Ooh.
Was it always active, though?
Well,
Do we know this?
That's one of the questions. That's sort of why we work on this question.
So, if I'm inferring too much here, is it like if we can learn when Mars went inactive,
Yes.
could that kind of give us some ideas about
much
what
time
might be
we've left?
happening? Do we have to worry?
Right. I mean, so a lot of the surface processes that we think of today on the Earth are controlled because of interior processes on plate tectonics, weathering, even things like bringing CO2 from the atmosphere, cycling it back through the, if you're cycling water from the surface back down into the mantle. So the question is, when, if ever, was that happening on Mars? Or if Mars is inactive today, and we can figure out when it was active, then we can start to say, okay, why? What happened? And could those changes that went from an active Mars to an inactive Mars, could those happen to us here on Earth?
All right, this is starting to make a little bit of sense.
Yeah.
So, another thing too, just because now you got my attention, could learning this information about when Mars went inactive compared to our planet and stuff like that, will this help answer or start to answer some questions about if we might be living on Mars one day as a species, if that's even possible?
That's an interesting question. And so I'm going to start out with just saying that exploration and the exploration side of science is something that I'm definitely interested in, but it's not something I have studied directly. But
Absolutely.
so I may.
You didn't strike me as like a jet propulsion kind of guy with building these huge domes and stuff.
The giant NASA mug doesn't give away that. But so one of the things about if you were to go to Mars, one thing that we have to think about a lot is the atmosphere, because we need oxygen. And the atmosphere of Mars is very different from the atmosphere of Earth.
Yes, and we can learn about it from the meteorites that you guys...
So one of the things that is important about the evolution of our atmosphere is there is a connection between the atmosphere and the geologic record. A lot of the gases in the atmosphere may have originated internally through volcanic activity. So when volcanoes erupt, they're releasing gases and things. So part of the question of what Mars's atmosphere is like now and how the atmosphere has changed is coupled to how the geology has changed.
Makes sense.
So if you're not producing volcanoes and you're not releasing gases through volcanic eruptions, that's going to be a very different kind of atmosphere then. So it all sort of ties
It all
together.
kind of comes together and it can help inform. That's pretty cool. So I got to ask you is, who or what influences you to do this? Did you just like wake up one day and go, I've got to study meteorites as they land to Earth? Or, where did this interest come from?
Yeah, so I started out in high school. I was actually working at a science center down in Atlanta as a volunteer at the Fernbank Science Center.
Atlanta, we're sorry about the Super Bowl, I
Yeah,
guess.
I know. I know.
It
So sad.
happens.
You were close.
So you're down in Atlanta working.
So I worked as a volunteer at the science center, and they had a planetarium and an observatory. And I was like it was a really fun place to work. And I took some classes there as independent study in high school. And it turned out that one of the astronomers there is actually also a planetary geologist. And he had there's a meteorite collection. And when you're a high schooler and Dr. Albin just sort of hands you this rock and it's like, here, hold this. It's from outer space. It's like,
Whoa.
This is like,
oh my God,
that's so cool. And so through working there and sort of working with Dr. Albin and the rest of the staff down there, I sort of just decided that this is something really cool that I really like, and I really love the aspect of it. It's space that you can hold in your hands, and it's bringing. What I really love about what I do is it takes this mystified huge space and it puts it in practical terms.
That's pretty cool. That would make sense to me.
And so we see that you're very enthusiastic about this. So what do you love most? Can you bring it down to one thing of what you do?
I really love field work. So as a geologist, I do a lot of field work outside, looking, mapping, going out, and just being outside I find just really fun, and it's a good way to do science that's not in a lab.
That actually, so to drop the veil a little bit, I do molecular biology, and for somebody that is stuck in a lab for long, long periods of time, to hear Steve say that
We're
makes
so
me kind of
envious.
angry.
I do a fair amount of lab work too, but it's nice to go out. Again, it's that practical sense of to me, I always think of geology as all of the other sciences visualized. It's chemistry, but you can look at two rocks and they have different colors. It's because chemistry. Or thinking about asteroids slamming into a planet. It's kind of a lot of physics, but it's visual.
Yeah, it makes sense. So you're speaking of planets. I got it.
Speaking about planets,
Yeah,
we
I
have
got
to
to
ask
ask you
you,
something. We were
what's
Wendy and I
Pluto?
were fighting about this.
What's the deal with Pluto?
I mean, does he count anymore? Is he in? Is he out?
Which side
is
are
he
you
he or
on?
she?
Alright.
I don't know.
So, like I said earlier, geologists are really obsessed with classification. And
Yes.
so, personally, I kind of think that this whole debate is just silly, right? It's a battle.
I suppose,
It's
but
the
it's
battle
fun.
of nomenclature over common sense.
Okay.
And I say that meaning how you classify things totally depends on what your purpose is, right? So like I started earlier saying about the rocky planets, right? If you want to classify things in the solar system by material properties, so you've got the rocky things, you've got the gas things, you've got the frozen ice things, those are things that as a geologist I care about because if it's rock or if it's gas or if it's ice, those are going to behave differently. So Pluto is very much a frozen, icy world. Which is a lot more similar to rocks than, say, gas.
Yes.
And so I'd separate the solar system into rocky planets, rocky planetary bodies,
And the
gas, frozen gas, and then ice. So, it sort of doesn't matter. If you're a physicist and you care about solar system dynamics and things so most of the reasons why Pluto was nixed as a planet
Trajectory.
is it orbits in a different plane. It hasn't cleared its orbit, which means it's not alone. It's part of the Kuiper belt, which is this belt of frozen asteroids out past Neptune.
Okay.
And so,
Influenced by something else?
yeah, so from a physics standpoint, it matters
Doesn't
whether or
make
not
sense.
you've
Okay.
cleared. If you haven't cleared the space around it, then the gravity of various things all influence it differently. And so, if you're interested in understanding how you went from early solar system to sun and dust and gas to planets all migrating around and you care about the motions and the physics, okay, well then it doesn't make sense to be a planet. If you
Right.
care about it as a rock, then it makes
I'm
sense.
going to call it a planet.
Yeah,
I grew up and it was a planet.
I put it
So-
in
Kind
there.
of sad to make it.
But
not
I also
but-
put the moon as a planet too.
Oh,
so
boy.
like,
All
All right, so we're gonna move on.
We're gonna move on before this gets
now.
crazy.
So
Wendy,
just
lead
to
the
take
way.
a break from the science, let's do some pop culture.
Oh, no.
This is everybody's favorite segment.
Don't worry. I'll
All right,
try to,
I'm ready.
I'll try to
Okay,
like,
ready?
play clean up.
All right, so
everything.
you're also open to answering the
All right,
questions.
I'm going to let
so,
Steve lead the way, but if
all
I
right.
know something he doesn't, I'll try to help out.
First question. So, which artist took home 5 Grammy Awards this year, including the categories for album, record, and song of the year? You guys know this.
I do know this one.
so I did not watch the Grammys.
Oh, but it's big news.
It is big news.
Apparently not in the places I go for news.
All right,
So wait, I'm gonna guess Adele.
yes.
Oh, okay, I got it right.
First question
knows.
down, he knows.
Well,
So.
I was debating between Adele and Beyonce.
Well,
It
it's
actually
funny.
was
That's
down
what the
to-
news is all
It
about.
was down to those two.
Okay.
Yeah.
And actually, Adele ripped her award in half, gave one to
Oh, that's
Beyonce.
nice.
There you go.
I
There you
like
go.
that.
The more you know. So, second question. Which American, Australian, Danish comedy film was released this past week featuring Batman? You guys
Is
know
it the
this?
Batman Lego movie?
Yes.
Oh,
Yep.
hey.
So the Lego Batman movie, exactly.
Which I saw the previews for. It looks terrible. I'm sorry.
Not as good as the original.
I mean, I didn't. We'll see about that.
Why
I
don't
love the
you- I
original
still
Lego
have to watch
movie.
it.
I saw the other Lego ones.
That
and
was
I-
good.
You know, I
Everything is
like
awesome.
playing with Legos, but I like looking at humans, so I just can't get it.
That makes sense. So this one is the one that I don't think you guys will get.
Okay.
So Jeremy Meeks swapped the jail cell for the catwalk at New York Fashion Week. What was his nickname in the past?
Oh,
Am I supposed to know who Jeremy Meeks
Yes,
is?
so
He was the mugshot dude,
yes,
wasn't he?
Yes, he was a mugshot.
Yeah,
dude.
so if I'm understanding correctly, he got arrested for God knows what, and his mugshot went online, and it just went viral.
He has like a
he's
model
yeah.
look.
Oh.
I have seen him. He's not.
Now, what's his
ordinary.
what's his nickname?
Oh, that I don't know.
Just throw something.
Yeah. Model dude.
The mugshot model.
Actually, I'll just give it to you guys. The hot convict.
Convict.
So that was his nickname.
The internet is a
Yes.
super
All right.
original place, guys.
Now we're down to 2 questions.
2 left.
Okay, so this one you guys know. Which team had the initial lead in Super Bowl 51?
Oh God.
Yes, Atlanta Falcons.
All right. Okay.
Don't remind me.
So last question. I think you should know this too. What is the name of the movie about Katherine G. Johnson at NASA who helped make Project Mercury and other missions possible?
Yeah, Hidden Figures.
Exactly.
Great.
Damn.
That was awesome. Yeah.
See,
4
that's
out of 5.
pretty
See,
damn
he
good.
knows what's going on.
I didn't get the fashion one. Okay.
That's all right.
all right.
I'm okay with that.
It's okay.
And I'm gonna have to go look up hot convict later, I guess. Gotta understand a
And
little
just
bit
to
more.
switch back into the science, how do you pronounce that crater that kind of just might have destroyed the dinosaurs?
Yeah, the one off the coast of the Yucatan Peninsula down in Mexico. I pronounce it Chicxulub.
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 How do we spell
I
that?
have no idea.
It
That's
sounds
what
like there's
so
an X in there
I
somewhere.
There-
I have to
is.
write that a lot in the papers and things that I write, and so I've just put it into spell check once, and then just always right click and get it. I have no idea how to spell Chicxulub. There are
Chicxulub.
X's and
Chicxulub.
C's and U's, and
If you can figure out how to spell it, we encourage you to go out and Google it. It'll be wonderful.
that's harder than doing the science. Let's just go say there.
All right, so I think we're running a little low on time here, so I've got to ask you, as is the spirit of our show and what we try to do here, what does science communication mean to you, and why is it so important to you?
Yeah, no, this is a great question. And science communication is so important because nothing that we do in the lab or the field matters if we're not effectively communicating it to other people, be it other scientists, the public, Congress, funders. If all we do is stay in the lab, then it doesn't matter what we're doing. The point of science is to create new knowledge, but it doesn't matter if you don't give that knowledge to other people. So you have to be putting this knowledge out there in a way that is, people want to hear it. So it's just really important, basically justifies everything we do is getting the science out there.
Awesome.
Thank you.
Wendy, you think we're done grilling him now? He's
Yeah,
good?
I think he's good. He's passed the test.
I like it. I like it. Well, Steve, I've got to say, thank you so much for joining us today.
Yeah, thanks for having me. This was
Super
really
interesting
Great deal.
stuff. Look out for Steve and Jaret. He's going to be publishing papers. He's going to be doing science things, maybe working in a museum in the near future. We'll
Maybe.
see.
He'll be
Fingers
handing a
crossed.
rock to you.
Yeah. Be the guy handing out
definitely,
meteorites.
for
See,
sure.
I'm starting to learn the lingo. Thanks, Steve. Wendy,
Thank
it's
you.
been a lot of fun.
Yeah.
Let's do this again. Oh, we can do one of these.
Handshake.
We can do one of these too.
Awesome.
It'll be cool. On that note, everybody, thank you so much for tuning in today. We're going to try to do a lot of these. We got a lot of really fun guests, a lot of people from different universities, And the goal is to try to demystify this stuff. So we hope you had fun along the way. Chicxulub, meteorites, hot convicts. This show has got everything. All right, thank you so much. We are Science Unplugged, and by all means, get out there and learn all you can about science. Thanks a lot, guys. Have a good one.